All right, hello there. Today we're going to be looking at pyramids. Now, when I say pyramid, my guess is you probably think about the pyramids in Egypt, the Great Pyramids, and those are definitely pyramids. They're going to fit all the descriptions that we're going to be talking about in this video, but they're only one kind of pyramids. Those are considered to be square pyramids because their bases would be squares. We're going to learn in this video that there are other kinds of pyramids besides square pyramids because the base of a pyramid doesn't have to be a square. It can be a different kind of polygon. So let's jump right in and take a look at some terminology that we need to know about pyramids. First of all, you can see I have two diagrams right there. They are both examples of pyramids, but there are some differences between these two which we need to kind of clarify first. The one on the top, some things you're going to want to need to notice about it. First of all, you'll notice that it has this point at the top. It's kind of one of the hallmarks of pyramids. They all have that kind of singular point where a number of the faces come together and meet at this one point right there. It's usually shown on the top of the pyramid, but it doesn't have to be. We could flip this pyramid over or on its side, and so that point doesn't have to be at the top of the diagram for a pyramid, but a lot of times it is. That point, G, that is called the vertex of the pyramid. All right, so that's the name of that point right there. Down here, we have this shaded polygon, right? It's called it would be named A, B, C, D, E. That is considered the base. A, B, C, D, E is considered the base of this pyramid. Now, going from the base up to the vertex, you can see we have a number of different triangles. All those triangles are called the lateral faces. So that would be triangle ABG, right? This one right over here, ABG, triangle BCG, and now I'm just going around this pyramid, triangle BCG. I would have triangle CDG, triangle DEG, and lastly triangle EAG. All of those triangles, they are called the lateral faces of this pyramid. So every pyramid is going to have one base, and it's going to have a number of lateral faces. And the number of lateral faces is going to depend on what shape the base is. In this case, you can see we have a pentagon for a base. This is called a pentagonal pyramid. And so its base has 5 sides. That would mean that there's going to be 5 lateral faces. Down here, you can see this is the next pyramid we're going to talk about in a few minutes. It's called a hexagonal pyramid because its base is a hexagon, so the base has 6 sides and it has 6 lateral faces, right? So all those triangles that go from the base up to the vertex, they're the lateral faces. All the segments where they intersect, so like this segment BG, those are called lateral edges of the pyramid. So let's do a little bit of labeling on here before we get too far along. That point there we call the vertex of the pyramid. This face down here is called the base of the pyramid. This triangle right here, that is one example of a lateral face. And the segments where all those lateral faces intersect, those are each called lateral edges, right? You'll notice we have another segment in here which we haven't talked about yet, segment GF. That has a name. That is called the altitude of the pyramid. It's a segment that's going to go from the vertex to the base, and it will be perpendicular to the base. So I don't have it drawn in here, so let's add in. It's going to be perpendicular to the base. So that would be a right angle where that segment is meeting the base. The length of that altitude is referred to as the height of the pyramid. So let's add a label in there. That thing there is called the altitude of the pyramid, or a lot of times it's just called the height of the pyramid. Technically the height is the length of the altitude, but that term altitude and height, they're pretty much interchangeable for what we're going to be doing. So that's one kind, that's just a generic pyramid. That's a pentagonal pyramid, but all those same terms would apply for any other kind of pyramid, a square pyramid, a hexagonal pyramid, a triangular pyramid, which we're going to see a little bit of. The one down here on the bottom, it's got something else special about it. It is called a regular pyramid because the base of this is a regular polygon. In this case, it's a regular hexagon, meaning that all the sides of this hexagon that is the base of this pyramid, all those sides are congruent and all the angles are congruent. All the lateral edges of this regular pyramid, they will all be congruent. So this would be congruent to this, and it would be congruent to that, it would be congruent to that, and those two edges that are kind of in the back side of the pyramid, they would also be congruent to all of these. What that means is if you look at each of those triangles that's forming a lateral face of this pyramid, they're all going to be congruent to each other by side, technically, because they have the lateral edges that are all congruent, and of course all the sides of the base will be congruent. So all those lateral faces will be congruent to each other, but they will also always be isosceles triangles. So every regular pyramid has lateral faces that are congruent isosceles triangles. Now if I look at the height of one of those triangles, you can see here, let me try and highlight it a little bit. Let me grab a different color. You can see I got this segment right here drawn in. That is the height of one of those lateral faces. That also has a special name. It is called the slant height of the pyramid, right? It's a height, so it's going to be perpendicular to this base of this triangle right there. That's called the slant height of the pyramid. It's represented by the letter L. For whatever reason, it's probably because S is oftentimes used to stand for side in a solid or in a polygon. So we don't want to use S again, so we use the letter L. So that thing right there, that is called the slant height of the pyramid, using the letter L to denote it. The altitude right here, this dotted segment in the middle, this dashed segment in the middle, that's the altitude again. And remember, that is what we call just the regular height. So try and keep that straight. We have the height of a pyramid, which goes from the vertex down to the base and is perpendicular to the base. We also have the slant height of a pyramid, which goes kind of down the side of one of those lateral faces. The altitude of a regular pyramid will always meet the base at its center. Now remember, the center of a regular polygon is the center of the circle in which that polygon could be inscribed, right? So keep that in mind. We learned that back in chapter 11. So there's all the terminology you need to know about pyramids. Let's take a look at a couple formulas that we're going to be using. First of all, we have a formula for the lateral area of a regular pyramid. It says the lateral area of a regular pyramid equals half the perimeter of the base times the slant height. Or if we were going to try and shorten that down, we might say lateral area equals 1/2 capital P times L, where capital P is going to stand for perimeter of the base, and the L stands for the slant height. Right? So that's how we would calculate the lateral area, which is the sum total of all the lateral faces of this pyramid. Of course, remember, in a regular pyramid, that base will be a regular polygon, so calculating its perimeter should be pretty easy. You'll just have to find one side of that polygon and then multiply it by however many sides there are in the polygon. So in this case, with this hexagon, if we knew, for instance, that that side right there was 8, then the perimeter would just equal 8 times 6, or 48. All right? So there's your formula for lateral area. What if we want to do the total area of the pyramid? Well, we know that the total area would be the area of the base, which we've been using as capital B to represent, plus the lateral area, right? If you're going to calculate the total area of this pyramid, you need to do the lateral area and also the base area right there. So we can write that as total area of a pyramid will equal capital B, standing for area of the base, plus 1/2 PL. And P and the L stand for what they stood for right up here, right? So you got to keep in mind that different pyramids will have different shapes of bases, which means you're going to have to use maybe different formulas for doing the capital B part, right? You might be calculating the area of a triangle in some pyramids, maybe it'll be the area of a square in other pyramids, or maybe the area of a hexagon like what we had right up there. So that capital B is calculating the area of the base, whatever shape it is, plus 1/2 perimeter of the base times the slant height. So let's put that formula to work right here. Let's do the following 4 things for this regular square pyramid. Notice that it does say it's a square pyramid, which means that all the sides will be the same. All the sides on the base will be 6. Well, first of all, what's the length of the slant height? Well, we can see this lateral edge has a length of 5, and of course this base would have a length of 6. But this slant height is the height of this triangle right here, which means it's going to bisect this edge of the base. So that will be a 3. And of course, this is a right triangle with a leg that's 3 and a hypotenuse that's 5, which means that this height right here, the slant height, we could find it using Pythagorean theorem. It would look like this. We would say 3 squared plus L squared equals 5 squared, which would indicate L squared is equal to 5 squared minus 3 squared. Or you might recognize that what we're looking at right here is a 3, 4, 5 right triangle. So the slant height would be the 4 in that. So what's the lateral area? Well, we know that the lateral area will be 1/2 the perimeter times the slant height. What's the perimeter? Well, the base has 4 sides that are all 6 units. So the perimeter would be 4 times 6, or 24. Lateral area is 4. So we're looking at 1/2 of 24 times 4. Half of 24 is 12, and 12 times 4 is going to give us 48. What's the base area? Well, that base is a square. So to find its area, we're just going to take one side of it and square it. So we'll take 6 squared in this case, which is going to be 36. So our total area, which of course is going to be the area of the base plus the lateral area, is going to be 36 plus 48. And 36 plus 48 should give us 84. So that square pyramid would have a total area of 84 square units. One more formula that we need to know for this section, and it's the volume for a pyramid. Thankfully, the volume for a pyramid is pretty easy to calculate. All we do is take 1/3 the area of the base, and we multiply it times the height of the pyramid. Not the slant height, the height of the pyramid. So, in kind of a shorter version of this would be volume of a pyramid equals 1/3 capital B, standing for, of course, area of the base, times H. And H is the height. Don't get confused. Don't think about slant height, right? So let's put that to work a little bit. Let's do so it's the same pyramid. I just kind of moved it down here. Let's find, first of all, its height. So that would be this measurement right there. Well, we know that this altitude is going to be perpendicular to the base. So if we kind of connect where that altitude comes down to an edge, you'll notice that what we have here is a right triangle, right? I know that this was the slant height, which we've already found to be 4. This right here is from the center of the base out to an edge, so it's going to be 1/2 of 6. That will be a 3. Now careful, this is not going to be a 3, 4, 5 right triangle, because in the 3, 4, 5 right triangle, the 5 is always going to be the hypotenuse. In this case, we have a hypotenuse of 4. So we have to do a little work with the Pythagorean theorem. We have to say h squared plus 3 squared equals, not 5 squared, equals 4 squared. So that would indicate that h squared is equal to 4 squared minus 3 squared, which is 16 minus 9, which is 7. So if h squared is 7, then h is equal to the square root of 7. And we're going to leave that as a radical. We'll do this in radical form. So I know the height is the square root of 7. What's the volume? Well, the volume is going to be 1/3 the area of the base times the height. That would be 1/3 of the area of the base, which we calculated over here already, 36, times the square root 7 for the height. 1/3 of 36 is going to be 12, and 12 times square root 7, well, we'll just write that as 12 root 7. So there's our volume for the pyramid. Okay, folks, that's it for this video. So we'll see you next time. As of right now, good luck on your homework.